Alright, we're going to look at graphing a traditional parabola one more time before we look at graphing a sideways parabola. This equation is given to us in vertex form, so to answer our very first question is actually quite simple. My vertex of this parabola will be at 4, negative 6. Because remember, our vertex will be at HK. My A here is a traditional 1. It's an imaginary 1 that's right in front of my curve. Now P, all I meant to say with P was where it was opening, if it was opening up or down. Because my A is 1, it's greater than 0, it's positive, so I'm going to open up. This is where the new information comes into play, the directrix. So now if you remember, the directrix is y equals, this time it is going to be y equals A, because K and Y go together. We're subtracting 1 over 4A. So if we just start plugging in some information that we know K is negative 6. And we know that A is 1. So negative 6 minus 1/4, we could just simply leave it as negative 6 minus 1/4. That is our directrix. The focus is a coordinate, if we recall. And then the coordinate for our focus, the H is left alone in a traditional parabola, and the K is shifted by adding 1 over 4A. So this gives us my focus coordinate. He has an H coordinate of 4. And just like we did above, we have negative 6. This time we're adding 1/4. And here's my focus. Lastly, my axis of symmetry, his equation is x equals h. So my axis of symmetry this time will be x equals 4. The last thing I need to do now is to plot my parabola. So, using my vertex, I'm going to start to plot some points. So my vertex is 4, negative 6. Let's go in one direction, then I'll use my symmetry. So if we go down to 3, we plug it in. 3 minus 4 is negative 1. Negative 1 squared is 1. And 1 minus 6 is negative 7. I'm sorry. 1 minus 6 is not negative 7. 1 minus 6 is negative 5. People are knocking on my door, distracting me. Plugging in x value of 2. If we plug in 2, we have 2 minus 4. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 minus 6 is negative 2. Then we plug in 1. 1 minus 4 is negative 3. Negative 3 squared is 9, and 9 minus 6 is positive 3. Going and do one more of 0. If I plug in 0, 0 minus 4 is 4, negative 4, and negative 4 squared is 16. 16 minus 6 will give me a coordinate of 10. Alright, I'm now able to plot my points. So 0 is at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1 is at 3, 1, 2, 3. 2 is at, we should plot these, negative 2. 3, 4, 5, 6. 3 is at negative 5. Ladies. And our vertex is at 4, negative 6. Now remember, my vertex is also my axis of symmetry, so the point should also be the same when I go to the right. And in my case, it's going to go off the board, but that's okay. On yours, you're actually able to plot the points. And all you need to do now at this point is connect your dots. And it goes on and on and on. Alright, we're now going to look at a sideways parabola that opens either to the left or to the right. This is number 3 in the J-term packet. So, looking at my equation, it's important to remember the very first thing I need to find is my vertex. But when an equation is set equal to x, the k is inside parentheses and the h is on the outside. So my vertex will be 3, and it'll actually be negative 1 because it's always minus really on the inside. My a here is 1/2. Therefore, my opening, because it is positive, I'm actually going to open to the right. Once again, this is because I'm set equal to x, I'll be a sideways parabola. The directrix. Just like the equation, it'll be set equal to x, and this time it'll be x is equal to h minus 1 over 4a. So we plug in these values that we know. H is 3 minus 1 over 4. My a is 1 half. So this gives us 3 minus 1 over 4 times 1 half is just 2. All right, the focus. When we're focused for a sideways parabola, my h is also shifted again by adding 1 over 4a, and my k is left alone. So let's plug values in again. This time, we'll have 3 plus 1 half. All I'm using is the data from right before when I'm subtracting 1 over 4a. And the k is negative 1. And my axis of symmetry this time is of the equation y equals k. So my axis of symmetry will be y equals negative 1. All right, now here comes the hard part. Sorry, Savannah will probably laugh at me because I said that funny. When we're making an xy table and the equation is set equal to x, I'm actually going to plug in values for y first, because it'll actually make my life a lot easier. What I'm going to do is I'm going to use my vertex. So 3, negative 1 is my vertex. Just as I was doing before when I went to the left one to the right one, I'm now going to go up 1 and down 1 in the y column. So if I go up 1 and down 1, let's plug values in for y. Plugging in 0. 0 plus 1 is 1. 1 squared is 1. 1 times 1 half is just 1 half plus 3, so it's approximately 3.5. Negative 2 will be the same because this is my axis of symmetry. Now, let's go up again. Plugging in 1. 1 plus 1 is 2. 2 squared is 4. 4 divided by 2 is 2, plus 3 is 5. It'll also be the same for negative 3. All right, and let's do another one. Let's do 2, and I'll sneak negative 4 in. I plug in 2. 2 plus 1 is 3. 3 squared is 9. 9 divided by 2 will be 9 halves, or 4.5 approximately, plus 3 is 7.5. All right, so let's go to plot these. And even though we are plugging in values for y in the xy table, we're still going to plot them traditionally with x and y coordinates. So I have an x coordinate at 7.5, 1, 2, 3, 4, 5, 6. So it's kind of off the charts over here. But he's all the way down at negative 4, somewhere over here. Now let's do 5 comma negative 3. 1, 2, 3, 4, 5, down 3. What about 3.5 comma negative 2? We also have one at 3, negative 1. We also have another one at 3.5 and 0. We have another one at 5 comma 1. Another one at 7.5 comma 2. Notice that my x values doubled up. It's going off the chart. However, now I have a sideways parabola opening to the right. Now in the examples that are coming up, you're going to have to complete some of the squares, and you're going to do it the exact same way, where you can factor out the a value from the first 2 terms. Good luck.